you very much, Maggie, and thank you very much, Pinfa North America, and Carolyn and Debbie for having us, and Tim Riley as well, for inviting us to do this webinar. And let me make sure you can see my slides here. All good? Great. All righty. So my colleague Chris and I today are going to talk about some of the drivers for safer chemicals. We were asked to speak about hazard and risk, and maybe if the often positioned as hazard versus risk, and we're not sure that's the right way to position these two. We're going to talk about ChemFORWARD, how it works as a centralized repository of what are called chemical hazard assessments, with a focus on safer alternatives, with a focus on flame retardants, and also on assessments of ingredients by trade name. And then we'll talk a little bit about targeted industry collaborations, some of the work we're doing in collaboration. First of all, there are numerous drivers for inherently safer chemicals. They all point in the same direction. The largest driver is regulations. For example, in Washington State, there was a recent law passed that will ban the use of all halogenated flame retardants in electronic casings. This is probably the most powerful driver. There are also a number of brand and retailer initiatives. Brands and retailers often will create restricted substances lists, or RSLs, which can include regulated substance, but often include substances that are of concern to public health, to NGOs, or substances that may be banned down the road. Certifications are a big driver. In the electronics sector, tools like EPEAT and TCO certified provide points for the use of inherently safer chemicals. I'll talk a little bit about that later, but it would include plasticizers, electronics cleaners, and flame retardants. These certifications create consumer and government procurement demands. There are NGO and advocacy campaigns against certain types of chemicals, typically chemical classes, PFAS, halogenated flame retardants, certain organophosphates. The UN Environment Global Chemical Outlook has established sustainable development goals and the need for adoption of the globally harmonized system of classification and labeling worldwide. In Europe, there's a movement toward safe and sustainable design and growing shareholder expectations of company performance and moving away from chemicals that create both human health, environmental, and business risk. So ChemFORWARD is a science-based organization, a collaborative entity that has created a database that is a repository of chemical hazard assessments that can be used to help identify safer alternatives, with the goal of driving toward an economy that is safe and sustainable by design, reducing hazard, risk, and waste. So what do we mean by hazard and risk? In the world of green chemistry, there's a very simple equation that risk is a function of hazard and exposure, or even risk equals hazard times exposure. So with an equation like that, there's two ways to reduce risk. One is to control exposure. The other is to control the hazard, or to use something that is of lower hazard. Now, the problem with typically and throughout most of recent time, risk is controlled through managing exposure, but that means that an entire other opportunity has been neglected, that of using inherently less hazardous substances. So one goal of green chemistry is to focus on the use of inherently less hazardous substance. So here, this image of the shark and the swimmer is intended to illustrate a little bit about hazard and risk. So a shark, and I mean no ill will to sharks, they are, some of them are inherently dangerous to prey. It can potentially cause harm, but not if left alone and not if you're not swimming by a hungry shark. So it's only when you increase the probability of harm that you are at risk. So risk is a probability of harm. Hazard is the inherent property of risk. And you really need to understand hazard to even do a risk assessment. One of the challenges of risk assessment is that it's really quite a bit more resource intensive than a hazard assessment. Hazard assessment is just a part of risk assessment, and risk assessment is often very tied to particular uses. And so risk assessment is very good to answer the question, is this, for example, chemical safe enough to use in its intended application? And it's very important for safety assessment because, frankly, even benign chemicals can be a risk if used inappropriately. Now, hazard assessment, which is usually used as comparative hazard assessment, helps you to answer the question, which is safer and why, based on which hazard endpoints. It allows you to compare chemicals, and it supports a process of continual improvement. It's also extremely useful for alternatives assessment when you are comparing alternatives and making a decision about which chemical to use. So hazard assessment, we often say that it's a lot easier to identify a hazardous substance than a safe stuff, an inherently benign substance. Here's a screenshot from one of the hazard summary tables in ChemFORWARD. It's broken out by 3 exposure routes. Green is low hazard, red is high hazard, yellow is moderate, gray is lack of data. And to say something is, say, a carcinogen or is a known skin sensitizer, that can be enough to preclude it from use in a product. But to say something is inherently benign, you need a whole lot more information. And that's why it's more challenging to say that something is benign than it is to say that it's hazardous. And so chemical hazard assessment is really versatile, and by default ChemFORWARD is a versatile platform because it supports what we call concurrent chemical management strategies. Now, years ago when I started in this field, a lot of people were focused primarily on eliminating high hazardous chemicals, or what might be called showstoppers. These are chemicals that were really problematic and were heading to be banned. And these chemicals often having them in a product would create a lot of business and regulatory risk. Think about bisphenol A in water bottles. And so people would move, say, great, all right, we're going to ban or eliminate this chemical from the use in our products. But often that seemed to be enough. They really didn't think hard necessarily about what are the hazard properties of the substitute of the chemical they're using in its place. And there could be regrettable substitutions, meaning you could move from, say, BPA to a chemical that's not BPA, but is very similar in structure to BPA, like BPS or BPF. And those chemicals, if you do use a process of toxicology called read-across, the best analog for looking at BPF and BPS is BPA. They're very similar. So if you moved from BPA to BPF, you weren't necessarily improving things, and you're also putting your company at risk for there being a ban for the replacement as well. So it's really important to do what's called informed substitution. And chemical hazard assessment can also be used in proactive design when you really step back and say, what does it mean to create something that is safe and sustainable by design. Is it safe? Is it circular? Can I think about the whole life cycle? Having that hazard information is critical for this kind of decision. Now, at one point, we thought of this as a progression, but really, I think if you think about most companies, they're probably doing all three of these strategies at the same time. This would be the more forward-looking one. This is the one, for example, dealing with PFAS right now, where there's a lot of movement to eliminate chemicals and then making sure the alternatives are indeed safer. So ChemFORWARD, we work hard to make sure that the chemical hazard assessments are of very high quality, and the value proposition of ChemFORWARD is that there's one profile per chemical. There's so much inefficiency. Having created the green screen method and program, I realized that often you'll find multiple versions of the same assessment, even by the same toxicologist. So there can be multiple versions out in the wild. They become outdated. We think that there's real value in putting all our eggs in a basket of one profile per chemical and having it be something that can be subject to continual improvement. The assessments in ChemFORWARD are based on proven existing methodologies. Currently we use a globally harmonized system of classification and labeling, GHS. We use Cradle to Cradle certified. It's not a new method for chemical hazard assessment. Qualified assessors own and maintain the data they create and enter into ChemFORWARD. And I think one of the biggest challenges of doing this was finding a business model that would work. Because part of the reason there's so many of these assessments out and owned by different assessors is that they're very expensive to produce. So an assessor needs to sell the same assessment over and over again to recoup their costs. And our business model is that we share revenue with the assessors. They own the data, we share revenue. And so that creates a win-win and allows them to want to participate in this community of practice. We use a peer review process. We hire third-party toxicologists to review every single assessment to make sure they're comprehensive, consistent, credible, and really equivalent. So we have a technical challenge process whereby anybody can challenge a hazard classification for any endpoint or even a physical property. And that way we can continue to improve these assessments. And we have a policy for including private data whereby the assessor and verifier can review private data to include in an assessment. So all of this together is designed to make centralized, high quality, one CHA per chemical. Also, the system is designed to harmonize between different programs. We use hazard bands, A being the best, F being the worst, U meaning there's not enough data to give it a hazard band, question mark meaning it hasn't been assessed yet and it's not a known bad. And then these are equivalent, like A would mean very low hazard, very low risk. It's equivalent to a cradle to cradle A. It's equivalent to, say, a green screen benchmark 4. The B is equivalent to, say, the EPA safer chemical ingredient list full green circle. And so it allows you to take the best of some other programs and to use a hazard band approach to expand what can be known and communicated about a larger number of chemicals. So I'm going to show you a little bit about how this works. This is where you come to log in. All of the chemical hazard assessments are available in all of the verticals. But what we do is we create these verticals. So this one here is the electronics vertical, and we break them into verticals because we allow people to search by function, by curated groups of alternatives, by material compatibility, by applications. And so it doesn't really make sense. And also we include regulatory and non-regulatory lists that are relevant to the industry sector. So of course, flame retardants aren't relevant to cosmetics, and there are many chemical functions in cosmetics that aren't relevant to electronics. So you can still access the same information, search for any chemical in the search by CAS number, INCI name, EC number, and it'll pull up the chemical, but the packaging it's in is tied to the vertical you're in. So here is electronics. We have about 100 flame retardants in here. Not all of them have full chemical hazard assessments. Some of them are synergists. And if you click the box, it will pull up all of the chemicals in the platform that are flagged as, say, flame retardants in the order, starting from the A's down to the F's and the question marks and the U's. Oops. There we go. Sorry, just lost my clicker here. There we go. So if you click on an individual chemical, then what you see is a set of tabs here. So here's a chemical, octaphenylcyclotetrasiloxane, and it has a hazard band of a B. It received a cradle-to-cradle rating of a B. The assessor there were no GHS hazard bands assigned by the assessor. There are it's an H413, which is a low, and it's got a classification for environmental hazard, but it's a low hazard. And there are no GHS harmonized classifications for it. It's a benchmark 3 on the TCO certified list, and it's not on the EPA safer chemical list. It was performed by Tox Services this date, and it's good for 5 years. And there's a summary. But you can also then look at hazards, chemical identifiers, physical properties, known functions and tags within our platform, which is it found on regulatory lists and non-regulatory lists. And by non-regulatory lists, we mean like NGO lists or manufacturer a restricted substances list, say the Apple RSL or the Google or Amazon RSL, that kind of thing. So now the way the system works is the same data is put into the back end by the assessor. Generally, a chemical hazard assessment, if it's printed out, is about anywhere from 80 to 100 pages. It's a lot of work to put one of these together. And some people think that the different methods produce different results, but they're really based on the same information. So for example, if something is a category 2 carcinogen, according to GHS, it would be red in the cradle-to-cradle system for cancer. It would be high in the US EPA safer choice scheme, or it would be medium in green screen. But the same data in the back end, by input by an assessor, translates into different views within ChemFORWARD, allowing people to use their preferred view, essentially. So if you go over to hazards, you can see you can toggle between GHS or cradle to cradle. The GHS, this one is the GHS view. It uses the most recent version of GHS. If something's in italic, it's low confidence. If it's bold, it's high confidence. If it's gray, classification not possible, there's no data. And you would list here what category level it is. So again, this was a category 4, so that's not very hazardous for aquatic toxicity, but it's got a little bit of hazard. And then here's the physical properties here. If you want to see it in the cradle to cradle view, you can click on any cell and it will explain in what's called the rationale why the assessor classified it the way they did. What data did they use that they felt deserved, in this case, that it's not classified, meaning it's of low hazard. And that's just by clicking on a cell. And here in the cradle to cradle view, it's organized a little differently and contains some endpoints that aren't necessarily found in the in the GHS view. So for example, cradle to cradle includes endocrine disruption. It breaks the aquatic toxicity out by species. It includes terrestrial toxicity, persistence, bioaccumulation, potential climatic relevance, things like that. So there are more hazard endpoints in cradle to cradle, and it can be very interesting to see the chemical in the two views. One, cradle to cradle is more precautionary than GHS. Now, one of the important applications, as we see it, for chemical hazard assessment is in certification. And pending this year, the EPEAT, the Electronic Product Environmental Assessment Tool, will be including ChemFORWARD assessments in support of their eco-label. It's a type 1 eco-label managed by the Global Electronics Council. In 2020, there were about $2.2 billion US dollars of purchases of EPEAT certified products. It's specified by a US government executive order. It's a multi-attribute criteria standard, and certifications are determined by points. And so EPEAT moving forward, it's still in process. It's being approved. Unless things change drastically, they will be accepting ChemFORWARD, Green Screen, Cyvera, and Cradle to Cradle assessments toward points towards certification. So the way it works is if you're using a flame retardant that has a ChemFORWARD hazard band of C or higher, you get 1 point. If you're using a flame retardant that has a flame retardant with a ChemFORWARD hazard band of B or higher, you would earn 2 points. And then you would need to document this to EPEAT to earn the points. TCO Certified has a different approach. They are a Swedish IT eco-label that uses chemical hazard assessments as part of their certification. They use what's called an accepted substances list, which includes flame retardants, plasticizers, and processed chemicals. And the next generation of the standard, it's renewed every 3 years, will hopefully be including high-quality ChemFORWARD CHAs in addition to green screen. So they basically have a list so that when somebody submits a chemical for approval, if it achieves a certain benchmark score and in the future a certain hazard band, then it's eligible for points towards the TCO certification. All right, so I am now going to turn this over to my colleague, Chris. And Chris, I'm happy to advance the slides if you like.
Yeah, thanks, Lauren. So while Lauren described the ChemFORWARD CHA repository and utility of hazard assessments, one thing to note is that that exercise is assessing the hazards of generic chemicals, and it's being used to help inform options for safe alternatives. So we recognize that chemicals don't exist as pure substances, so we developed a SAFER program to review and verify trade name ingredients. The idea being that once a user of the application identifies a potentially safe alternative, they can find a safer for that ingredient that has an acceptable impurity profile, so an actual trade name ingredient that they could use. The companies on the screen are ones that have received the SAFER designation for certain ingredients. We hope to continue to expand this program. And just to reiterate, the CHAs in the ChemFORWARD system are theoretically pure chemicals. And so once you identify a potentially safe alternative, you would then be able to find a supplier for that chemical that provides that safer material by using this SAFER program. I think we can go on to the next slide. So here we're talking a little bit more about the details of the SAFER program and how it works. And so what we do is there's a few steps to it. We ensure the safety of all the chemical constituents while protecting CBI, and I'll show that on the next slide. And we use the existing CHAs in our repository on those generic chemicals to reduce the cost and increase the consistency of the material review. And so if you have a trade name material that has 4 or 5 chemicals in it, you know, all of those assessments may be available within the repository, and then their corresponding hazard bands would be pulled in to show that, yes, all of the constituents are C or higher and meet additional criteria. All of that criteria is on our website, but in short, all of the chemicals above 1,000 parts per million need to have a C or higher, plus meet some additional criteria, like not being having red for persistence or bioaccumulation and aquatic toxicity. And they also, for anything above 100 parts per million, that's what would need to be disclosed. And those would have to pass between 1,000 and 100 parts per million screening level list to show that they aren't known VADs. And so also with this, it's being conducted by a third party. So we're building that customer confidence with that rigorous third party review against those criteria. And it's providing a portable claim to distinguish those trade name materials from other, other materials that may have different impurity profiles. So we can go to the next slide and look at a few examples. So here are some examples of 2 flame retardant entries in our system for SAFERs. What's being shown are the product summary tabs. There are 2 other tabs that go with it. So this tab gives a brief description of the product, its function, and any applications, so that you know you're kind of picking a functionally appropriate SAFER alternative. The other tabs give even more details on the products, and the middle tab on the hazards is where we show the ingredient breakdown and the scores for each of the chemical, and we can see that on the next slide, where here this is how the hazard data for the SAFER listing would be shown. Clicking on the highlighted chemicals would then go to the summary page, that specific chemical, where you get even more details about that material. You can see here, this is an example where some of the chemicals were redacted to protect that CBI. They're still reviewed by the third party, but when they're entered in this system, not even ChemFORWARD can see what they are, but then they show up with the corresponding hazard band grades to show that they do meet the criteria. On the next slide, we can go into some other activities at ChemFORWARD. So in addition to being the software platform and CHA repository, ChemFORWARD also tries to work in a collaborative manner to host targeted industry collaborations. And so one of those is the Electronics Safer Chemistry Collaborative, which includes the participants with those logos on the slide. And the goals of the collaborative are to populate a shared repository of CHAs relevant to the industry. All of the members benefit whenever an individual company contributes a CHA. And they also all work together in a pre-competitive way to accelerate the identification and adoption of safer chemicals in different areas. The participants are using the ChemFORWARD platform to support product innovation, and they all share a desire to continually improve initiatives that protect worker health. And we'll go into those initiatives a little bit more on the next slide. So here's a list of the ongoing priorities for the Safer Chemistry Collaborative. So one of them being evaluating non-halogen flame retardants to ensure that they are indeed safer. We have a project on identifying and evaluating low VOC solvents, looking at plastic additives, and with an extensive inventory of plasticizers, doing CHAs for common ingredients used in coatings, cleaners, and degreasers, evaluating coating and cleaning formulations. And then some future projects are looking at alternatives to intentionally added PFAS chemicals, safer adhesives, and safer inks and pigments. On the next slide, we'll go into one of the initiatives, ChemWorks, which was recently launched with support from Apple to accelerate the adoption of safer cleaners and degreasers. Cleaners and degreasers account for some of the highest use materials in electronics assembly. And some of those chemicals used in cleaners and degreasers have potential health hazards and create health risks due to the volume of exposure. And so while it's important to require suppliers to maintain strict safety measures, one of the strongest methods a company can employ to protect workers is to select safer materials from the start. And so, ChemWorks is designed to come up with a registry of certified safer cleaners and degreasers, and provide a free screening process for formulations of cleaners and degreasers to help optimize them, and ensure that they are containing safer ingredients and inherently safe materials. And then the next slide will give even more detail on ChemWorks as well as a few other initiatives. So these safer chemistry solutions of electronic collaborative, involve a number of things, but one of particular note is that with the flame retardants, there are almost 100 flame retardants and flame retardant synergists in the platform. As Lauren went over, they're organized by hazard band function, application, material compatibility, and while not all of them have CHAs, they all have scores in some way, and it's that portfolio is available in our electronics vertical. We're also working with the Green Chemistry and Commerce Council to create a standalone vertical with a focus on solvents that are low VOC to formulate low VOC products. The low VOC focus is driven by regulations in China, and the collaborative participants want to be sure that moving from VOC to low VOC solvents won't result in moving to more hazardous substances. So working to avoid those regrettable substitutions. And in that vertical, again, the solvents are organized by hazard band, boiling point, vapor pressure, and also have Hansen solubility parameters with them. And we're working towards having a solvent selector release in the future. And as I mentioned on the previous slide, there's a lot of activities on cleaners and degreasers. What we're doing is, in the first step, using GHS criteria to find what a safer cleaner, safer coating is from a worker perspective. Next, we're generating CHAs for common ingredients. And then with a clear framework and supporting data for the individual chemicals, we're rapidly generating screening reports that we call formulation ingredient intelligent reports. And these reports help support the creation of and modification to safer cleaners through the application of that criteria. And then lastly, we're committed to those growing the volume of trade name assessments, having the ability to quickly identify potential safe alternatives and the material that you would ultimately use, within your product development process. And then our last slide we'll just wrap up with some summary and conclusions. You know, CHAs are increasingly important components of alternative assessments and are increasingly integrated into standards, regulations, and product development. Selecting chemicals that are well characterized and fully assessed for hazard is critical to avoiding regrettable substitutions. And since manufacturing process can vary, it's also important to review the ingredients not only by the CAS number, but obviously looking at all the constituents within a trade name material. And ChemFORWARD is committed to scaling and sharing actionable CHAs to support informed substitution in response to voluntary or regulatory chemical restrictions, product design development, eco-labels, other certifications, and just to help manage a sustainable supply chain. So I think with that concludes the content we wanted to present, and can move on to taking any questions.